In this video, I'm going to show what a VFD does in a heating hot water piping system. So if we don't have a VFD, the pumps here, well, let me back up. Let me describe this system here. You have two boilers here that are going to take this water. They get heated up in the boiler and then comes out of the boiler and gets pumped up to your air handling unit coils. Okay, so in this detail they're showing 4 air handling units. So supply hot water piping here, goes through the coils, treats the air, and it returns back to the boiler to get retreated. So the VFD works in conjunction with the speed of the motor and the pumps. So if we didn't have a VFD, these pumps would run at full speed all the time. So as a property owner, you wouldn't want the pump motor to run at 100% all the time because it's going to add more wear and tear on the whole system, as well as use a lot more energy than what's necessary. So the VFDs are controlling your motor speed by varying the frequency and voltage being pushed to those pumps to turn the motor. So VFD stands for variable frequency drive. So the VFD needs a power connection to it, and it also needs control wiring to it. Okay, so the control wiring goes from that VFD and talks directly to the pump motor, but it also has to be smart enough to take the information from the system and tell the pump what to do. So that's why on these hydronic systems, there's always a differential pressure in the system. So as you can see here, usually the DP is always pretty far out on the piping system. I think for the most part I see about like 75% down the pipe run is where usually you see the differential pressure probe going in. So let's talk about that briefly. So on our coils here, we're going to have control valves that are going to open and close as the demand requires. So as our air gets passed through these air handlers and gets treated, the space is going to dictate how much hot water it wants to pass through that coil. So if we're downstream here from this air handler and we're satisfied and we don't want to add any more heat to it, it's going to close a control valve here, which what that will do is create pressure on this line. So let's say that we're in the same building and they're all kind of doing the same thing where they're all brought up to temperature at the same time and they're all satisfied. Well, what's going to happen is all 4 of these air handling units are going to start closing their control valves and not allowing hot water to pass through them, because obviously pulling the hot water across the coil is going to create a heating element for that airstream, and it's going to continue to heat the space. So if we don't want any more heat, we got to close the valve and stop the flow of water. Well, what that's going to do is it's going to start closing all 4 of these control valves on the inlet side of these air handling units. So what does that do? It is going to drive the pressure up on the supply side water. So this differential pressure is going to understand that, where basically we have a probe in on the supply side here, and we have a probe here on the return side. So when we have a varying difference here, this sends a signal back to that VFD to slow down the motors of the pumps. So for instance, say these pumps are pushing at 30 psi on the inlet side of these, and we're closing all these valves, so that just keeps climbing the pressure here. Well, this is going to tell that varying delta that, hey, we've closed valves here, and we got to wind down the speed of this pump motor because we just don't need that flow right now. So if we didn't have a VFD here that was reading that and taking that information into account, these pumps would be running at 100% and just creating more and more pressure on that system on the inlet side. So obviously that causes more wear and tear on the pumps and the bearings, and also the piping, and it's going to be a big electric draw as well. So these differential pressures always have to be installed to send a signal back to the VFD on what to do with the pump motor and adjust the speed. So the VFDs basically are good for electrical savings. They're reducing the wear on system components, and they're also offering better control, better temperature control for these systems as well. They're making the pump behave like a valve, delivering only the flow the system actually needs at the moment. So anyhow, if you have any questions on VFDs, I'd be glad to answer them. Thank you.